Greetings to you wherever you are. We want to do salt analysis for 2025 Neco protocol. And so the salts for this year to analyze are, as we have it here, potassium sulfite, and lead nitrate. These are the salts for analysis: potassium sulfite and lead nitrate. These are the two salts given by Neco in this 2025 for analysis. And so the students will be required to identify potassium ion, sulfite ion, that's trisulfite ion, then the lead ion, as well as the nitrate ion, triazonitrate 5 ion. So these are the three ions students will be required to identify. The 4 ions, rather, students will be required to identify. That is the potassium ion, the corresponding sulfite ion, then lead ion, as well as the triazonitrate 5 ion. So these 4 ions will be required to identify. However, there is no special reagent to identify this potassium other than by flame test. So we'll be identifying potassium ion by the flame test. So we use the flame test to identify potassium ion. Then reagents will be used to identify this other ion. So let's begin with the potassium ion with the flame test. So here is the salt containing potassium. Then here is our source of flame. What we'll simply do is to check out the flame test. All right. Here is a glass rod, and I think I have in here, I have concentrated hydrochloric acid, which we'll be using. All right, to confirm potassium, you know that potassium gives lilac color with Bunsen-burner flame. Bunsen-burner flame will give lilac color of potassium. That's the only way. Apart from that, sometimes these higher ions are not even identified. But if at all students will be required to identify potassium, it has to be through flame test. All right, so let us collect some sample of the salt. Let's collect some sample of the salt. Here is the salt. Let's drop the salt here. And a sample of the salt. A salt sample. The salt sample. Then let's quickly test with the flame and see what the outcome will be. And so this is a glass rod. Let's dip the glass rod into the concentrated hydrochloric acid. All right, let's ignite the flame. So switch on the flame. That is a Bunsen-burner flame. So potassium should give a lilac color. Potassium should give lilac color. So let's check. That's it. That's lilac. That's lilac. And potassium should give lilac color. Here. That is the lilac color. Okay? And just make a little more of the hydrochloric acid on it to collect more sample of the salt again for the test. So this is flame test. That's lilac. That's lilac. See, lilac. Lilac. That's bright orange. It's lilac color. It's a typical feature of potassium salt. That is how potassium is confirmed. And so let's identify let's hit the nitrate, lead nitrate. This is lead nitrate. This is lead nitrate. Let's hit and see what the outcome will be. So all we need to do is to collect some quantity of the salt into a boiling tube. These are boiling tubes. So I have some quantity of lead nitrate here in the boiling tube. Let us heat and see what the outcome will be. As usual, this is my Bunsen burner. Bunsen burner. That's the flame. So let us heat and see what the outcome will be. All right. All right, it's being heated. Okay, you can hear some sound. Can you hear some sound? Can you hear some sound and see some? Oh, you hear some sounds and some gases evolving. That is decrepitating sound. Decrepitating sound. You can hear, you can see gas evolving. Okay. All right, we want to test the sulfite. Earlier we tested the potassium to confirm the presence of a potassium by means of the flame test. And now we want to confirm the presence of the sulfite, SO3 ion, sulfite ion. So what we need to do is, let's collect a small sample of the salt. Let's collect a small sample of the salt into a test tube. By the way, the salt is white. Let's collect a small sample of the salt into the test tube. All right. So what are we adding? We'll be confirming it with, we'll make a solution of it, add barium chloride to it, then followed by HCl. So it should dissolve. It should dissolve if we add barium chloride to it. So let us, to form precipitate with barium chloride and dissolve with HCl. So let's add distilled water to it. Of course, a soluble salt. You see, it dissolves. It's a soluble salt. It dissolves to give a colorless solution. It is a soluble salt. You see, the salt dissolves to give a colorless solution. So what we need to do is let's collect small quantity of the salt. Let's collect small quantity of the salt into about 2 cm cube. All right, that's more than 2 cm cube, but anyways, let's work with it. I needed about 2 or 3 cm cube because I'll still be making you need of it. Okay, so 2 cm cube of the salt. Let's now add barium chloride. If we should add barium chloride, we're supposed to get white precipitate. We should have white precipitate. Let's add barium chloride to it. Let's add barium chloride to this sample. Here is our barium chloride solution. Let's add to it. It's supposed to have white precipitate. See a clear colorless solution. So on doing that, we should have white precipitate. Let's add barium chloride to it. Good. Look at it. There's white precipitate. We are having a white precipitate here with this barium chloride. Hope you can see it clearly. Yeah, you see, it's white. See it? Yes, white precipitate with the barium chloride. So barium chloride will have a white precipitate here with barium chloride. I hope you can still see it. Yeah, that's white precipitate. So let's add HCl to it, dilute HCl to it, and see what will happen. The precipitate is supposed to actually dissolve. Let's add to it. Oh, look at it, look at it, look at it. In essence, this is a clear solution now. The precipitate dissolve. The precipitate, look at it, it has dissolved. I hope you can see. The precipitate is soluble with HCl. The precipitate will dissolve. So with the dissolving of the precipitate, what we'll have is SO3 minus, SO3 2 minus, SO4 2 minus, and CO3 2 minus present. That should be the observation. Sorry, that should be the inference. SO3 2 minus, SO3 2 minus, comma, we say SO4 2 minus, and CO3 2 minus present. This should be a report for the addition of barium chloride. So after barium chloride, the sample dissolved. So in that case, since it dissolved, we'll simply report that SO3 is present because it did not dissolve with effervescence process. All right, to the third sample. Here is the third sample. To the third sample, we are going to add this potassium chromate, potassium dichromate, that's tetraoxochromate 6, potassium tetraoxochromate 6. You see, before adding, the color is yellow. The color is yellow, so let's add and see what will happen. Let's add and see what will happen. Okay, so here is what we'll have. Okay, this yellow color is gradually fading to green. I don't know if you can see that. Look at the original yellow color. The original yellow color. This other one is fading to green. So with time, if I keep with time, it will to turn completely green. That is a reduction there. That's reduction. Reduction. The sulfate ion there is reducing this oxidizing agent. The sulfite ion is, look at the yellow. It's pure yellow. Look at the yellow, this other one. Though looking, but there is it's a yellowish green or greenish yellow, so to say. Yellowish green or greenish yellow. But this is the main yellow color. I splitted this video into two for the length of it. So immediately after this, the video where I recorded the test, observation, and the inference of this analysis will drop. So there are two different videos. One is for the experiment, then the other one is for the recordings of the results and observation. So the next video you see will be the recording of the results and the inference, observation and the inference of the report. Thank you.